Let's take a look at this example of exponential growth. In 1968, the U.S. federal minimum wage was $1.60 per hour. In 1976, the U.S. federal minimum wage was $2.30 per hour. Assume the minimum wage grows according to an exponential model where n represents the time in years after 1968. First thing we're going to do is find an explicit formula for the minimum wage. So let's start by writing down the formula for exponential growth. So let's say I'll use W sub n for the wage n years after 1968. So that's going to equal W sub 0, which is the initial wage, in this case in 1968, times 1 plus R, which represents the growth rate, to the nth power, which is going to represent the number of years. So let's go over here and write down some information that we know. We know that in 1968, the wage was $1.60, right? $1.60. Now, we're going to call that, 1968, we're going to call that year 0. All right, so n is 0, and this is W sub n, which is the wage in year 0. Then we know in 1976, okay, that the wage was $2.30. Now, what would the n value be there? Well, that looks like it's, 8 years after 1968? So that's going to be n equals 8. So we know that the W sub 0, the starting wage for 1968, is $1.60. All right, we know that, so we can plug that in. That's going to be a constant. We don't know the R. We don't know the rate, so we need to figure that out. Then the n and the W sub n are inputs and outputs. Let's really highlight that fact. Let me highlight this n and this W sub n. All right, these are our inputs and our outputs. So we have to find the values of W sub 0 and R so that we can plug in some n and get the output of the wage. All right, so how do we find R? Well, what we're going to do is we are going to take some particular data point that we know. In this case, we know after 8 years that the wage is $2.30. We're going to plug that in. Actually, let me highlight that in yellow because that kind of makes more sense since I've used yellow for the n W sub n. We're going to plug that in for n W sub n so that we can solve for R. All right, because we have to figure out what this growth rate is. We don't know this growth rate. And this piece of data is going to help us figure it out. Okay, so we have this equation now by plugging in a particular data point that we can use to find and figure out what the R value is. So now we're just going to do a little bit of algebra and figure that out. So why don't you pause the video and solve for R. Start by dividing by 1.6. When you're done, unpause the video. I'll solve it as well, and then we'll see if we got the same value for R. All right, I got 4.64% for R, and I got that by dividing by 1.6 and then taking the 8th root of both sides and subtracting 1. So be careful not to round here. Punch this whole thing into your calculator, and then you can go ahead and round after you get your answer. So now that we know what the rate is, we can write our formula. Using this model here, we'll know that the wage after n years is the starting wage in 1968 of $1.60 times 1 plus 0.0464, rounded to the nearest hundredth, to the nth power. So now we can use this equation to answer the rest of the problems. Let's take a look at those other problems. We're not necessarily going to solve them here, but so B says, what does the model predict for the minimum wage in 1960? Hint, you can pick a negative number for the exponent to find the minimum wage in 1960. All right, so if we were going to find, let's see, we're getting a little crowded here. If we were going to find 1960, what would the exponent be? All right, well, that's 8 years before 1968. So what would the exponent be? Yep, it'd be -8. All right, so that's fine. You're going to put a -8 in for n and punch it out, and you'll get your answer for the wage 8 years before 1960. All right, part C says the U.S. federal minimum wage was 50. The U.S. federal minimum wage 50 years after that should be an S, 50 years after 1968 in 2018 was $7.25. On the other hand, the minimum wage in Washington state was $11.50. How did this model do predicting the minimum wage 50 years after our initial value? Well, just plug 50 in for n and see what you get and kind of compare it and see what did it come out to better model the U.S. federal minimum wage or the Washington state minimum wage. All right, I hope that helps.